We have been learning how to solve systems of equations. Now we're going to learn how to classify systems of equations. Your essential question is, how do I classify systems of equations? Your learning intention, I'm learning to solve systems of equations and to classify the system of equations. So you've got two warm-up questions. Solve these systems of equations, pause the video, and see if you can solve them now. Well, I do hope you tried to do those on your own. Both of these can be solved with elimination. If I'm looking at the first one, I know I've got a positive 9y and a negative 9y. If I add them together, I have eliminated my y value, and I am left with negative 18x is equal to 9 plus negative 9 is 0. Divide by negative 18. And x is equal to 0. But you still have to find y. So I think I will use the first equation to find y. Negative 8x plus 9y equals 9. Negative 8 times 0 plus 9y equals 9. 0 plus 9y equals 9. 9y equals 9. When I divide both sides by 9, y is equal to 1. So my solution for this set is the point 0, 1. For the next one, it might be easiest to solve for y and then substitute in. Otherwise, we're going to have to multiply everything by 8 to get opposites. So what shall we do? Shall we solve for x or multiply everything by 8? Well, let's scale by multiplying everything by 8. 8 times negative x is negative 8x. 8 times negative 4 is negative 32y. 8 times negative 2 is negative 16. Now the 8 and the negative 8 will cancel out. The 32 and the negative 32 will cancel out. I am left with 0 is equal to negative 32. When does that happen? It will never ever happen. Guess what? Guess how many solutions you have? No solutions. Why would two lines not have a point of intersection? What kind of lines are those? Those are parallel lines. Okay, there are different ways to classify systems of equations. The first way is by its number of solutions. An independent system has exactly one solution. In other words, there is one point of intersection. So if it's independent, you will have one solution. If it is dependent, then it has an infinite number of solutions. And if you're thinking about it, it is the same line. That's the only way you can have that infinite number of solutions, if it's the same line. Okay, so independent and dependent depend on whether or not they have solutions. What about consistent? Any system is considered consistent if it has at least one solution. So let's think about this a little bit harder. If it has exactly one solution, it's independent, but it will also be consistent because it has exactly one solution and it has at least one solution. So the systems will be independent and consistent. What about dependent? Dependent has an infinite number of solutions. Consistent has at least one. So a dependent is also consistent because it has at least one. I forgot to put the S on the end there. Okay, what about an inconsistent system? Well, an inconsistent system has no solutions. So if we're looking, parallel lines have no solutions. Parallel lines would be an inconsistent system. On the first one, we had one solution. So that would be independent and consistent. So let's identify the following graphs as independent or dependent systems, consistent or inconsistent systems. So graph 1, what is it? It has exactly one solution. Exactly one solution is independent. Is it consistent or inconsistent? And consistent. Because it has at least one solution. What about the next one? This is one line on top of the other. So that would that be independent or dependent? Well, this would be dependent because it is one line over the other. Now, would it be consistent or inconsistent? Dependent and consistent. Remember, inconsistent is if you have no solutions. What about graph 3? Those are parallel lines. Is it independent? No, it doesn't have one solution. Is it dependent? No, it's not the same line. Is it consistent? Does it have at least one solution? Nope. Inconsistent. So if you're looking at an independent or dependent system, those will both be consistent because they have a solution. If you're looking at parallel lines, it is simply inconsistent. So, why do we even need to know about systems of equations? Because most businesses use them. Whether they call them that or not, they use them. So, The owner of a frozen yogurt stand considers different pricing options for a serving of yogurt plus toppings. For what price of toppings do the options give the same price? So, the first one is $3 for the yogurt and 75 cents per topping. This one is $4 for the yogurt plus 50 cents per topping. What are your variables? Well, X will be the number of toppings, and Y will be the total cost. So, if we're looking at the first, does that $3 change? No. You get charged $3 for your yogurt, period. So you start off with $3 plus 75 cents per topping, 0.75x, and that will give you your Y, which is your total cost. For the other one, it's going to be $4 plus 0.50x is equal to Y. So as you're looking at this, both of those equations are equal to Y. If they're both equal to Y, they have to be what? If you said equal to each other, you would be correct. So what we want to find out is when 3 plus 0.75x is equal to 4 plus 0.50x. Okay, I'm going to get rid of my variable first. I'm going to subtract 0.50x from both sides. Three plus 0.25x is equal to 4. We still don't have our solution yet. 3 plus 0.25x is equal to 4. Subtract 3 from both sides. (0.25x) is equal to 1. Okay, before you freak out that we're using decimals, stop and think. 0.25 is a quarter. How many quarters are in $1? If you said there are 4 quarters in $1, you would be right. So what is the solution to the problem? 4. At 4 toppings, both charge you the same amount. With 4 toppings, you pay the same amount. If you get over 4 toppings, then the $4 plus 50 cents per topping would be the better buy. An opening night for a new play, a theater sold 639 tickets for the main floor and the balcony. The balcony tickets were $17, the main floor tickets were $24. Let X represent the number of main floor tickets sold and Y represent the number of balcony tickets sold. They sold $5,824 more in main floor tickets than in balcony tickets. How many of each type of ticket were sold?